All right, now we are to the area of similar figures. This one's a bit different because I'm doing it in blue. I'm not going to do it in yellow. I'm just hoping you remember something. I don't think it's something you need to like stress over, but I hope you remember it. So they have some similar figures down here. They have regular hexagons, they have rectangles, and they have right triangles. And they gave the sides of this right triangle as 3, 4, and 5, Pythagorean triple. They gave the size of this right triangle as 6, 8, and 10, another Pythagorean triple. In other words, these are similar. And the ratio of their similarity would be 3 to 6, which reduces down to a scale factor of 1 to 2. Okay. If we talk about their perimeters, in other words, the distance around, 3 plus 4 is 7 plus 5 is 12. Down here, 6 plus 8 plus 10 is 24. Well, when I reduce that down, I get 1 to 2. When we talk about area, we have to do 1/2 base times height. So my base in this case is 3, or you can call it 4 if you want to, but the other one's going to be the height. So we have 1/2 times 3 times 4, which is half of 12 is 6. Down here, we have 1/2 times 6 times 8, and half of 6 times 8 is 24. Now we're up to 6 and 24. Well, if I reduce that down, I get 1 to 4. Over here for the rectangles, we have a 4 and a 6. When I reduce that down, I get 2 to 3. For perimeter, we have 2 plus 4, that's 6, plus 2 plus 4 is another 6, so that's 12. Down here we have 3 plus 6 is 9, plus 3 plus 6 is another 9, so that's 18. When I reduce down 12 to 18, I get 2 to 3. Up here for area, 2 times 4 is 8. Over here, 3 times 6 is 18. When I reduce 8 to 18, I get 4 to 9. Okay. Up here, we have 16 to 12. We're going smaller now. 16 to 12 reduces down to 4 to 3. Then when we talk about perimeter, 6 times 16 and 6 times 12 is going to give you 96 to 72. That's another 4 to 3. And then when we talk about area, we could figure out the area for each, and they went ahead and did that for us. And when you reduce it down, you get 16 to 9. Okay, so for perimeter, we end up with the same ratio as our scale factor when we're talking about similar figures. But for area, what happened? We went from 1 to 2 to 1 to 4. How do we go from 1 to 1? Well, 1 to 1 is fine. How do we go from 2 to 4? Well, you multiply by 2, kind of, sort of. But when we're talking over here, we didn't just multiply by 2, because we didn't multiply the 1 by 2. We went from 2 to 4 and then from 3 to 9. How do you get from 3 to 9? Well, you multiply by 3. But what it really is for area, the ratio of areas is squared. So we square 1, 1 squared is 1, and we square 2, 2 squared is 4. We square 2, 2 squared is 4. We square 3, 3 squared is 9. We square 4, 4 squared is 16. We square 3, 3 squared is 9. So if you want to find the ratio of the areas, you're going to have to square your scale factor. If you want to find the ratio of the perimeters, then you keep the exact same scale factor. And if you turn the page, see, that was interesting. That's why it got blue. If you turn the page, they'll say the exact same thing up here at the top. If the scale factor of two similar figures is A to B, then the ratio of the corresponding perimeters is A to B, and the ratio of corresponding areas is A squared to B squared. And that's it for this section. There's nothing else I need to go over. There's nothing else I need to talk about. All we've got is classwork and homework. And I know you're saying, wait, that was pretty quick. And yes, it was. But there's not much classwork and homework to do. So we're talking about page 479 for classwork, numbers 5 and 9. Check them, make sure they're right, and then you do the homework, which is numbers 7. Now I realize we didn't do anything in yellow, so there's nothing you really need to memorize, but you do kind of need to know that, and there will be a question about this on the test. So don't exactly expel it from your thoughts. Just kind of remember, instead of worrying about memorizing formulas for this particular section, just kind of remember if it's perimeter, it's the same ratio, and if it's area, it's squared, because area means you're squaring it. Just like when you give a unit in area, it gets squared. For volume, I bet it's going to be cubing the ratio, and for volume, I bet it cubes the units as well. Same kind of idea. So just remember, if it's area, it's going to be squared, and if it's perimeter, then it's not. It's the exact same thing. So I will talk to you later. You will have a review for this section. It is not going to be an easy review, but it'll get you really prepared well for the test. And the test for this section, of course, will come after the review. And I think this is a fun chapter. Sorry, because it's all pretty simple. Straightforward. You just got a lot of formulas you're going to have to memorize, but most of them you already know, so just practicing it should be good. Talk to you later. Love you guys. Bye.